Hello students, welcome to Analog and Digital Electronics Laboratory. In the previous experiment, we have done with the half adder, half subtractor, full adder, full subtractor. It's a simulation part by using Xylem software. And in today's session, we will see experiment number 5. The title of this experiment is Entered Variable Map and 8:1 Multiplexer. And in this session we are going to use simulation. So this will be a simulation video on this 8:1 multiplexer. As you can see, the highlighted portion of this statement, here we are going to develop a VHDL code for an 8:1 multiplexer using Xylem software or Xylem simulator. Okay, so it's a hardware part we are going to see in the upcoming session. So these are all the design part, procedure part with respect to hardware. Okay, and you can see the implementation part for the hardware is also given in this file. Okay, so the circuit diagram for the hardware, and this is our part, simulation part. As you already gone through the multiplexer, demultiplexer in your theoretical part of your AD subject. So I'm not going to take much time to explain about what is a multiplexer, okay, what are the application of multiplexer and all. A simple statement about multiplexer is a multiplexer is a device which consists of a multiple input and only one output. Okay, so this is the simulation code, VHDL code that we are going to use to simulate our 8:1 multiplexer. Means 8 input will be there and 1 output will be there. Okay, so as you can see that I have already opened this Xylem software. Why I have already opened means it will take some time. Initially it will take some time. To save that time, I have already opened this Xylem, and you can see in the left side of the top corner of this window the 4BP19CS000. That is a project that I have created in the previous video or in the previous session, and within that project I have created one device file that is XC3S2004FT256. Okay, so this is the common project that I will use for all the simulation part. If you don't know how to create this project of a 4BP19CS000, okay, you can use your USN, and that you can go for the previous simulation video of the half adder, half subtractor, full adder, full subtractor. There in a greater detail I have talked about how to create the project, and within this project how to create this device file. Okay, so now we are going to use this same project and same device file. So whenever you open up this existing project and project that device file, as you can see that sometimes along with that some old files will come along with this. For that you have to first make sure that it is in the implementation part, and click on this device file and click right, and within this you will get an option called remove. Okay, so I have applied that remove. Okay, so that's why you can't see the remove here. So all that all those source files like adder, half adder, full adder, half subtractor, full subtractor, all those files I have already removed. Okay, similarly, once you're done with this part, then you can go for the behavioral simulation. Again, click on this device file and click right button. Okay, the next again you will get that remove. Okay, so click on that remove. So all those bench, okay, test bench for the full adder, half adder, full subtractor and half subtractor, okay, all those files will also be removed. Now all that files has been removed. Okay, now we are going to focus on the 8:1 multiplexer. So hence we are going to use the same project file, okay, same project and same device file, but now we are going to start with the new file. Okay, so this will be as it is. Okay, as you know that within this project we are going to use this device file, and within this device file we are going to create a new source. Okay, and we are going to use the VHDL module, and here I will write the file name as it is a multiplexer. Okay, so I'm going to use a simple mux. Okay, otherwise I will go for mux 8 is to 1. Okay, mux 8 underscore 1. Okay, so you can see that the location will be Xilinx. Within that 10.1 ISC folder, within that I have this my project file. Okay, for VP19CS000. So make sure that the VSTL is clicked, the file name has been given, then click next. Okay, so now it is asking me for this port name. Okay, that also we have done in the previous session. Okay, for adder subtractor. Okay, but instead of this one, I can go for directly writing in the program. Okay, so I'm not going to mention any port name here. Okay, see, this is the one more alternative that what I can use. Okay, so either you can write, okay, A is input, B is input, then sum is output, carries output, like that we have used, right? But here I'm going to use 8 input. Okay, so it is better that instead of going for this uh, wizard, I will just click next. Okay, and next I will click on the finish. Okay, it will take some time. Okay, now you can see that here within this device file I have got this mux 8 underscore 1 okay file, and rest of the things you can see that it is already written. Okay, library IEEE is imported. Okay, and some other logic, standard logic of a 1164, arithmetic logic, unsigned logic, all these logics have been imported. Okay, so all those are nothing but they are libraries. Okay, so now what I will do, in place of this entity mux 8 underscore 1, okay, and end, all these things I will replace with this code. Okay, just for to save the time, what I'm going to do, I'm just simply copying all those things. I'll copy these things and I will paste. But you have to write this program, okay? Because in the exam you have to write this program, okay? So next I'm going to paste over here, okay? Now you can see that here my file name is here mux 8 underscore 1, but here the entity name, that is nothing but the file name only, it is mults. Okay, so I have to change here, so it will be mux 8 underscore 1. Okay, and next one I will keep a kind of arrangement like this. Okay, will tell you what I am doing here. So let me keep it in this kind of aligned mode, so that you can understand. Okay, and here this architecture part will be get separated. Okay, you can see that here the entity is mux 8 underscore 1 means here also that entity should be closed with that same name. It is mux 8 underscore 1. Okay, now next one, here the architecture name, you can see that here it is mux 8 underscore 1 is there. So here I will simply use mux. Okay, and here the mults, okay, that is nothing but our entity. So here I have taken as a mux 8 underscore 1, mux 8 underscore 1, that is my entity. Okay, and architecture name here is mux. So similarly it should end with the that same name, that is mux only. So that is end will be mux only. Okay, so here you can see in this program there is an entity called mux 8 underscore 1. Within that I am going to use port. One is called select. Okay, this is a selection port. Okay, which are nothing but a kind of bus, which is nothing but a kind of bus. Okay, here LSB value will be 0 and MSB value will be 2. Okay, so totally 0, 1, 2. Okay, so totally we are going to get 8 selection lines because 2 to the power 3. Okay, 2 to the power 3 because the 3 are there, 0, 1, 2. So total 2 to the power 3 means we will get 8. So totally 8 selection lines will be there. Okay, the next one you can see D0, D1, D2, D3, D4, D5, D6, D7. These are nothing but our input. These are the input for our multiplexer. And Y is the output. Okay, so this is the port values. Okay, port values for our device. Means which are the input, which are the output. Okay, next one, in the architecture you can see mux of entity mux 8 underscore 1 is what we are going to do. We are going to begin with the process. Here we will first select the one of the selection line. Okay, one of the selection line, as I told that totally 8 selection lines will be there. One of the selection line will be allotted to one of the input of the multiplexer. Okay, for example, you can see that selection. Okay, totally 3 bits are there, or the 3 values are there. Okay, so totally there are 8 will come. Okay, so that's nothing but 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. Okay, so all that selection lines, that is nothing but 0, 0, 0, that will be allotted for the D0. 0, 0, 1, that will be allotted for D1. 0, 1, 0, that will be allotted for D2. Similarly, at the end, 1, 1, 1 of the selection line will be allotted to D7. Okay, that is what you can observe here. You are beginning, then the case, okay, selection based upon the selection of this bit of this selection line. If it is a 0, 0, 0, then the D0 value will become the Y value. Means the value of the D0 will become the output. Okay, so if the D0, if the selection line is 0, okay, so at that time period, okay, at that time period, whatever the value of D0, if it is a 0, then Y will get 0. If D0 is 1, then Y is also become 1. Means whatever the input, that will become the output. Okay, means whatever the output of this D0, that will become the output for this Y. Okay, so similarly for 001 cycle, okay, 001 clock cycle, okay, at that time whatever the value of D1, that will become the output for the Y. Okay, if it is a 0, 0, if it is 1, it will be 1. Okay, irrespective of other values. Okay, similarly 010 at that cycle, okay, whatever the value of D2, okay, that will become to the Y value. Okay, so like this it is going to move up to this final value, that is 111. Okay, 111, so that is a D7 value will become its value will become Y value. Okay, when others, okay, when others, that means that once you are done with this 111, again if you are going to start with the 00. Okay, at that time whatever the D0 value will be there, that is going to become the output for this Y. Okay, so end case, end process, and end mux. Okay, let us see how this program is going to exhibit this 8:1 multiplexer behavior. Okay, so yes, I have written the program. Okay, so here let me close this. You can see that here mux 8 underscore n underscore 1 dot vsd asterisk. Asterisk means it is not at all saved yet. So I will click on this save. Okay, you can see that the file has been saved. Okay, students, after writing this program, okay, next one we have to verify this program is having any kind of errors or not. For that, you can see in the implementation part within this project and within this device file, we have this mux 8 underscore 1 mux, okay, where mux 8 underscore 1 is nothing but our entity and mux is our architecture. And once you click on this single click, and below our table you can see that is a process table. You can see synthesize XST. Okay, click on this checkbox and double click on this check syntax to verify that whether it is containing any kind of errors or not. It will take some time. and you can see that process check syntax completed successfully, which indicates that it does not have any error. And if you want to see its RTL schematic diagram, you can just double click on this RTL schematic. Now you can see that this particular multiplexer, 8:1 multiplexer, having the 8 input and the 3 selection lines, that is from 0 to 2. Okay, and y is the single output. Okay, if I double click on this, so you can see that its internal structure. Okay, D0 to D7 are the input, and the selection line, because totally 8 input means the 8 input are there, means totally the 3 bits will be used for allocating that, that is for 000, that is a 000 for the D0, 001 for the D1, similarly for 111 for the D7. And any one of them, the selection line is active, at that time that corresponding input will become the output. Okay, so let me close this one. And if you want to see the technology of this 8:1, double click on this, and you can see that the same kind of output. And once you double click, you can see that it's a complete technological architecture. Okay, and once you double click on one of them, you can see that again the gates are there, and they correspond to with their own truth table and Karnaugh map. Okay, which is a additional information for you. Okay, once you are done with this one, just close this. The next one, within this file mux 8_1, just click one more, that is a new source. And within that we have to use the test bench waveform. So here I'm going to write mux_test bench tb. Okay, in the same location, then click next, then next, finish. Okay, it is taking some time. Let me create for one more time. There is some error it seems. So mux_tb. This is the test bench waveform that I'm going to use. Click next, next, and finish. So let me go for the property. Let me see. Okay, here the simulation. Click apply and OK. go for everyone. Okay, let me go for one more time because I don't know what kind of error it is exhibiting. Sometimes it will go for such kind of errors. Go for one more time, mux underscore db. Okay, now you can see that it is a test bench waveform. We have to give the waveform here, so it is a combinatoric. So click on this, and next one, click finish. Okay, and next one, you can see that in the selection line you have to pass the values. So that is the thing, but this will be for 0, 0, 0, and this will be 0, 0, 1, and this is 0, 1, 0. Next one is 0, 1, 1, and here 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and finally we will get 0, 0, and 0. Okay, so here with respect to that, the selection line of this is 0, selection of 1, selection of 2, so it is a 0, 0, 0, 0, 0, 1, 0, 0, 2, sorry, 0, 1, 1, sorry, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, then 1, 1, 0, 1, 1, 0, sorry, 1, 1, 1, and finally 0, 0, 0. Okay, so this is for the D naught. Okay, so here whatever the value you want to give, you can give. For example, let me go for here high. Okay, and here for this D1 I will keep it high here. See here I can randomly I am selecting. Okay, uh, of this D5, D7. Okay, these are randomly I am selecting. Okay, just to verify that whether this for that particular selection lines, whether that particular D0 to D7, okay, any of them are giving the output, okay, in the Y. Okay, once you're done with this one, again save it. Save it. Once you're saved, just to close it. Okay, the next one, go to this behavioral simulation. There you will get this test bench. Okay, then next click on this Xilinx ISC simulator. Double click on this simulate behavioral. It may take some time. Okay, now you can see that this is 3H0, that is nothing but 0, 0, 0. Okay, 000. Okay, at that condition, if I keep this timeline over here, whatever the values of the D naught, that will become the output in the Y. That is, here D naught is 0, hence Y is also 0. Okay, now in the second one, that is here, whatever the values of the T1, that will become output in the Y, that is also 0, because T1 is 0, Y is also 0. Here, next in the third one, that is nothing but what is the value of T2, that is will be the output of the Y. Okay, so D2 is 0, so Y is also becomes 0. Now next one is D3. Okay, so here D3 value is 1. Okay, so output will become 1. Okay, so similarly, next one D4 value is 1. Okay, Y value will also will become 1. Okay, irrespective of whatever the other input. Okay, so here it is following only the D4. Okay, D4 value is 1, so Y is also 1. So once you go to the next cycle, okay, so here whatever the value of d5, that will become the value of y. Okay, similarly for this one, the value of d6 will become the output in the y. And next one d7. Okay, d7 value is 1, so y is also become 1. Okay, and finally next one, that is again it is coming back to its original, that is a 0 0 0. So again it is coming to the d0 value is 1, so y is also 1. Okay, so this is how we can use this Salin's simulator to understand this 8:1 multiplexer. Okay, if you click on this box, you can see that how this selection lines. Okay, that is what I have made. Okay, so here 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 and finally 0 0 0. Okay, so this is the thing what we can observe from this output. Okay, so this is all about your um, 8:1 multiplexer. Okay, somewhere we have come across with some kind of disturbance. Okay, you have to neglect that disturbance. Okay, uh, okay, so that is all about this lab program. Thanks for listening. Bye.